Hello everyone, let's talk about an easy problem on Leetcode today. Remove duplicates from sorted array Leetcode number 26. It states that given an integer array nums sorted in non-decreasing order, remove the duplicates in place way such that each unique element appears only once. The relative order of the elements should be kept the same. Then return the number of unique elements in nums. Uh, Consider the number of unique elements of nums to be k. To get accepted, you need to be doing the following things. Change the array nums such that first k elements of nums contains the unique elements in the order they were present in nums initially. The remaining elements of the nums are not important as well as the size of the nums. Return k. Okay, so basically what they are saying is like we are given a number, say array nums, and in that there are some elements which are duplicate, but it's in non-decreasing order. That means it is either in the increasing order. The elements are either in the increasing order, or they are the same, or they are equal. And what we have to do is like we have to just change this array in place and return the size of the number of unique elements as at the end of it, so that we can and they have the what you say test in such a way that they expect the numbers, and then they remove, like they call the remove duplicates, and actually the answer should match their array which they would have already pre-specified. So for example, in this case they give input as nums, and what we return is integer 2, right? Because we have only two unique elements, 1 and 2 in it. We don't have to return nums or anything, and you can also see it from the syntax here. Let's now jump into the solution space. One of the solution that can easily be applied is the hash maps, right? Whenever we talk about duplicates, I think this is the easiest point that we can think of. And another solution we can think of is like using a new array, but I think that is ruled out because we have to do it in place. And last approach can be that we use a two-pointer approach. So let's talk about bit about the hash map solution. So what we can do here is like we can just create a map, and whenever, or set, I think maybe set is a better approach, but hash set, hash map, I think um, use a similar approach. So what we can do is like when we see a new element, we just add it to the set, uh, and uh, um, and also add it to the like keep it in the array and increase the what you say pointer L, right? Assuming that L is the place which signifies the number of unique elements we have seen so far. So then we see 0 again, so we just ignore it. So we increment R. Then we see 1, because we have now when we see, because we will keep on incrementing R like a normal pointer to cover the extent of the array or the end of the array. So we see 1 for the first time, so we increase L as well and move 1 here. And because 1 was not present in the set, we add it to the set. Next time when and then we increase R. Next time when 1 comes again, 1 was present, so we will not increase L, but we will have L somewhere here. But R will keep on staying there itself. Uh, and then eventually we have R at 2 again. 2 was not present in the set, so we will increment it and move L again to index 2. And then eventually 3 comes in and 4 comes in, like depending on like whenever the new element comes in which is not present in the set, we will just increment L, um, and then we find our answer. But let's think about the time complexity here. Time complexity is O of n, but space complexity here is O of n as well, because we are using extra hash set data structure. And this does solve the problem in place and will be an accepted solution, but can we do better? And the answer lies in the point that the array is actually already sorted. So can we use it somehow? And the answer is yes, right? Because whenever the two elements change, they are in the sorted order. So we know once 0 has occurred till this point, that means 0 will not occur in the future because the array is sorted. We don't have to use any extra data structure here. So what we can do is like we can use the same approach that we just talked about, like L being the point till which we have encountered the unique elements, and R represents a point so where we have traversed the array so far. And what this will do is like whenever we find a new, we will keep on incrementing R normally, and as soon as we find what you say new element which we have not traversed so far, we will just increment L and move that element to the start of the or to the point of L where we have encountered the unique index, or the end of the unique index elements in the array. So I mean this will become clear when we look at the example. So suppose this is our input array, and initially L will be at 0 and R will be at 1, because R will always ensure the extent of the array, because we have covered L at 0. At least the first element will always be unique, right? Because we don't, there's only one element, so it will be unique. Now what we will do is like if AL is equal to AR, and then the answer is yes, because both are 0, so we will just increment R by 1, because R will keep on incrementing till the end of the array, and as soon as we reach the end of the array, we will just stop the iteration. We will just increment R. Now R is at index 2, and the value here is 1. So we can see that AL and AR are not same. That means now we have found a new element. So we will just move 1 to the start to the index 1 now, because and increment L as well. So now this array of us, like here, will have two unique elements so far. Now we again get 1 and 1 again, because what you say 1 was 3 times. AL equal to R, yes, and AL equal to R again, yes. So we will just keep on incrementing R. Now things become again interesting. We find 2 this time, as we have incremented the R, and AL is not equal to R, right? So we will again move 1 to the end of the unique subarray which we have created so far, or like which is visible but not programmatically separate memory space. But I think this is what we can call. And as soon as we have it, we will just move 2 to the end of the new what do you say to the end of the unique array. Then we will again increment 2, because we found 2 again, which is again not unique, because AL and AR are same. Now we again find 3, and this time AL and AR are not same, because AL is 2 and AR is 3. So we will just increment L as well and move 3 to A of L, and eventually we find 4 as well. Like in this case again, AL and AR is 3, but I think eventually we will reach to the end of the array, and again the elements are not same, and we will again reach the end goal here, which is that is like 4 will move to index 5, and that's it. I think then we are done, because we have reached the end of the array. And one thing to remember here is that we don't have to return L, but L plus 1, right? Because they ask for the size of the unique index. So even though and computer science in general, all the programming languages have um, uh, array started from number 0, so size will be L plus 1. So I think now that we have understood the explanation, like the algorithm, now let's jump into the code. Now that we have understood the solution, I think coding should not be that hard, but let's first read the constraint here. So it says that nums.length is at least 1 and less than 3 into 10 to the power of 4. And nums are between 100 and minus 100 and 100, and it's a sorted non-decreasing array. So I think, yes, so we don't have to check about the length or something of the array, so it's at least 1. So what we can start with is like we can create a left pointer and right pointer, and we will always increment the right pointer, because we are calling it right because this right pointer is always left, it will always be right of left pointer. So yeah, um, yeah, don't think it's like it's starting from the right or end of the array, something like that. But um, and I think once we have this defined, what we can do is like, sorry, r will be 1 because yeah, it should be the next element. So if nums l is equal to nums r, that means we don't have to do anything, just increment r. Else what we can do is we can define, uh, what we will do is like we will increment l, then we will set nums l equal to nums r, right? Because that's what we want, and increment r as well, right? So I think they should do it. And at the end, like we talked about it, like we should return l plus 1 because that's what is the size of the array that they want, not the index of the last unique element. So yes, so this one should work out. And now let's submit the problem. Awesome. Yeah, this works out and looks good to Leetcode as well. Now that looking at the code, I think I can simplify the if condition a bit. So what I can do is like I can, because I'm always incrementing r plus plus regardless of the case, so I can just move it out. And what I can do is like if nums l is not equal to nums r, in that case only I will just increment l and set the value, but r always has to be incremented. And I think this code should also be like should be accepted by Leetcode. Yeah, so that's it, folks. I think that's it for today. Thanks, and if you like the video, please do hit the subscribe. Have a nice day.